Every second, the universe bombards Earth with radio waves from pulsars, X-rays from accretion disks, gamma-ray bursts from collapsing stars, and gravitational waves from merging black holes. Your body feels none of them. Here's the shock. We evolved to detect only vibrations in air, sound, and a narrow band of photons, light. The cosmos speaks in languages our senses never learned. To hear it, we had to build new ears. Radio dishes collect faint photons with wavelengths kilometers long. X-ray telescopes focus light so energetic it would melt normal mirrors. And LIGO measures space-time distortions 1,000 times smaller than a proton. In the next few minutes, you will clearly understand how 5 cosmic signals have hidden themselves within this vast space.
Before we begin this journey of exploration, please hit the subscribe button to help support us in bringing you even higher quality content in the future.
It's so quiet out there. Just silence. A few stars. The universe seems peaceful. But I've been on this ship long enough to know that peaceful usually means I'm missing something important.
Peaceful? Minto, the universe is screaming. It's just that your ears were never designed to hear it. Every second, billions of neutrinos pass through your body. Radio waves from the Big Bang wash over us. Gravitational waves stretch and squeeze the Earth.
Messages? From where? From what? Are these signals just noise? Or do they actually carry structured information that tells us something specific about the object that sent them?
From dying stars, from black holes, from the birth of the universe itself. 5 invisible signals, each one tells a different story, and together they form what astronomers call multi-messenger astronomy, the ability to observe the same cosmic event through completely different physical channels. A neutron-star merger, detected simultaneously in gravitational waves and gamma rays, is not just twice the information. It's a fundamentally richer picture of reality. 1931. Karl Jansky was trying to find the source of static interfering with transatlantic radio calls. He discovered something unexpected. The Milky Way itself was broadcasting the first radio waves from space.
The galaxy emits radio waves? Why? Is it a specific process, or do different things create different kinds of radio signals?
Electrons spiraling in magnetic fields, supernova remnants, pulsars, even the afterglow of the Big Bang itself, all of them scream in radio waves. We just needed the right ears. And the beauty of radio astronomy is that these long wavelengths can penetrate dust clouds that block visible light entirely. We can see into the hearts of stellar nurseries where stars are being born, places completely opaque to optical telescopes.
So the universe is not silent. It's broadcasting on frequencies we can't hear. Radio waves are just one channel. And Jansky didn't just discover a signal. He proved that the universe is active in a spectrum we never knew existed. He opened the first door.
Radio waves were the first window into the invisible universe. But there are others, each one more extreme than the last. Cosmic Signals 1. Radio waves. And we can hear them? Like a radio station? So So if we took that pulsar signal and converted it directly into sound, we'd actually hear the beating of a dead star.
And we can hear them? Like a radio station?
That's the sound of a pulsar. Some are so regular, they're more accurate than atomic clocks. We use them as cosmic timekeepers. The fastest pulsars, called millisecond pulsars, rotate hundreds of times per second, a city-sized sphere of neutronium spinning faster than a kitchen blender. And their timing stability is so precise that we've used them to map the solar system's orbit through the galaxy, and even to detect the subtle warping of spacetime caused by passing gravitational waves.
So radio waves reveal a universe invisible to our eyes. Pulsars, supernova remnants, even the Milky Way's magnetic field. These aren't just dots on a map. Each source is a physical process broadcasting its existence across the galaxy.
Exactly, Minto. The radio sky was our first clue that we were almost blind. But radio waves are just the gentlest messenger. The next ones are born in violence, in places where stars are torn apart and matter itself is pushed to its limits. Cosmic Signals 2. X-rays. They come from the hottest, most violent places in the universe. Black holes devouring stars, neutron stars colliding. Supernova remnants heated to millions of degrees.
X-rays? Like the ones in hospitals? But from across the universe? So the same physics that lets us see a broken bone also lets us see a star being torn apart by a black hole?
When matter falls into a black hole, it accelerates to near light speed. The friction heats it to millions of degrees. That heat emits X-rays. The black hole's last meal is broadcast across the cosmos. And X-ray telescopes do more than just detect these events. They can measure the temperature, density, and chemical composition of the hot gas swirling around the black hole. We can read the menu of its last meal from millions of light years away.
So X-rays are like an X-ray machine for the cosmos. But if the atmosphere blocks them, that means for most of human history, we were staring at the sky completely blind to this violence. How much of the universe's true story did we miss?
We missed almost all of it. For centuries, we were prisoners of our own atmosphere. Only by launching telescopes into space did we finally see the universe's true face. Every new messenger forces us to admit, we are not the center of the story. We are just beginning to listen. Cosmic Signals 3. Gamma rays, the biggest explosions. Gamma rays, the most energetic form of light. They come from the most powerful explosions in the universe, gamma ray bursts. In a few seconds, they release more energy than the sun will in its entire lifetime.
A few seconds? More energy than the sun's entire life? What could cause that? That's not an explosion. That's a fundamental rearrangement of matter on a scale I can't even process.
Neutron star mergers, or the collapse of a massive star into a black hole. These events create jets of matter moving at 99.9% the speed of light. They fire gamma rays across the universe. And here's what makes gamma ray bursts cosmologically important. They are so bright that we can see them from the very edge of the observable universe. They are our deepest probes into the early cosmos. Some of them exploded when the universe was less than 1 billion years old.
So gamma ray bursts are the universe's death screams. But here's what I don't understand. These are the most powerful events since the Big Bang, yet without satellites, they're completely invisible. Why would the universe hide its most extreme truths behind a curtain our eyes can't penetrate?
The universe isn't hiding, Minto. It's broadcasting on all channels. We just had the wrong receivers. Our eyes evolved to see the sun's light, not the death of stars. But now, we've built new eyes. And the next 2 messengers don't even need light at all. They are the whispers and the music of space-time itself. Cosmic signals. 4. Gravitational waves. Ripples of space. Einstein predicted them in 1916. It took 100 years to detect them. They are ripples in the fabric of space-time itself, caused by accelerating massive objects.
Ripples in space-time? Like waves in the ocean? But the ocean is made of water. What is space-time made of that it can ripple?
When 2 black holes orbit each other, they create ripples that stretch and squeeze space itself. By the time these ripples reach Earth, they change the distance between mirrors in LIGO by less than 1,000th of a proton's width. But here's the truly radical implication. Gravitational waves are not made of anything. They are vibrations of the metric field, the mathematical structure that defines distances and durations. When a gravitational wave passes, the distance between objects changes. Not because something is pushing them, but because space itself is stretching and squeezing. It's pure geometry in motion.
That's the sound of 2 black holes colliding. First we saw the radio sky, then the X-ray sky, and now we're hearing space-time. We're not just mapping objects anymore, we're feeling the tremors of reality itself. This is a different kind of knowing.
A different kind of knowing, exactly. Gravitational waves let us hear the universe's deepest collisions. But Minto, the final messenger, makes even this seem ordinary. It's a particle so ghostly that trillions pass through us every second, and we never feel a single one. Yet it carries secrets from the hearts of exploding stars. Cosmic Signals 5. Neutrinos. The ghost particles. Trillions pass through your body every second. They almost never interact with anything. To detect them, we built the largest particle detector on Earth, buried a mile deep in Antarctic ice.
Trillions through my body every second? And I don't feel a thing? So right now, as we're speaking, an entire invisible rain of ghost particles is passing through us from every direction?
Neutrinos are almost massless. They have no electric charge. They pass through matter like it's not there. But once in 1 billion, one will hit an atom. And when it does, it creates a flash of blue light. That's how Ice Cube sees them. And this property, their near total indifference to matter, is precisely what makes them so valuable. A neutrino produced in the core of the sun takes just 8 minutes to reach Earth, carrying direct information about the fusion reactions happening right now. Photons, by contrast, take hundreds of thousands of years to random walk their way out of the sun. Neutrinos are real-time messengers from the hearts of stars.
Even the sun sends neutrinos? Every fusion reaction inside it produces them? So every second, the sun is not just shining light, it's flooding the entire solar system with a silent neutrino rain that carries the blueprint of its core.
The sun, supernovae, black holes, all produce neutrinos. They carry information directly from a star's core. Light can take 100,000 years to escape the sun's center. A neutrino takes 2 seconds. No other messenger is so direct, so honest. They are the universe's most intimate confession. 5 cosmic signals. 5 senses we invented for ourselves. Radio waves, our first crude ears hearing the galaxy's hum. X-rays, penetrating the hidden heat of black holes. Gamma rays, capturing the ultimate depths of stars. Gravitational waves, listening to space-time itself breathe. And neutrinos, touching the ghosts that carry secrets from the core of exploding suns. Each one invisible, each one tearing down another wall between us and reality.
So the universe is not silent. It's broadcasting on multiple frequencies. We just had to learn how to listen. Every new cosmic signal we discovered didn't just add information, it revealed an entire layer of reality that was completely hidden before.
Every new detector is a new sense. Radio telescopes gave us ears for pulsars. X-ray telescopes let us see black holes. Gamma-ray satellites caught the universe's biggest explosions. LIGO let us hear the ripples in space-time. IceCube captured the ghosts. And this is not just a list of instruments. It's a demonstration of a fundamental principle. What we can observe is limited by the technology we build. The universe has always been broadcasting in all these channels. For billions of years, the signals were there. We just didn't have the receivers. The invisible universe is invisible not because it's hidden, but because we hadn't yet evolved our technology to the necessary sensitivity.
And together, they tell us the full story. Not just what the universe looks like, but what it does, how it lives, how it dies. And the most exciting part? We know there are things we still can't detect. Dark matter, the quantum structure of space-time. The universe is still keeping secrets.
The invisible universe is not a void. It's a symphony in 5 movements. Radio waves are the deep bass. X-rays are the urgent strings. Gamma rays are the thunderous percussion. Gravitational waves are the resonant cellos. And neutrinos are the ghostly chorus, singing words we are only beginning to translate.
And we are learning to hear it, slowly, piece by piece. But Kyler, what about the messengers we haven't discovered yet? The ones we don't even have instruments to imagine.
5 cosmic signals. Radio waves, X-rays, gamma rays, gravitational waves, neutrinos, each one invisible, each one a window into a different universe. Together, they are the voice of the cosmos.
Thank you, Kyler, for teaching me to listen. The universe is not silent. It was just waiting for us to build better ears. And we're still building. The next generation of detectors is already being designed.
That's what I do, my boy. I help you hear. The universe is singing, and we are finally learning the words. But the song has verses we haven't heard yet. That's what the next instruments are for.
The invisible universe. Not empty, not silent. Full of messages waiting to be heard, and we are the generation that learned to listen across the entire spectrum. That's our place in this story.